Hello, and welcome to Adding Fractions Part 2 with the Fraction Wall Virtual Manipulative. It can be found at mathbots.com/manipulatives/fraction wall. And here it is. What we're going to look at is adding fractions with unlike denominators. In the previous video, we considered adding fractions with like denominators. In other words, the denominators were the same. We're going to do this by considering the expression 1/3 plus 1/5. So 1/3 and 1/5, they have different denominators. One has a denominator of 3 and the other has a denominator of 5. And this expression is certainly an actual value, because if we go over to our fraction wall and we take 1/3 and we take 1/5, put them together, that's a definite length. So fraction tower or fraction train that we make out of these, that has a specific length, and we like to know what fraction goes with that. What we have here is an expression, not an individual fraction. An individual fraction is a number that we can write in the form n divided by d, where n is the numerator, d is the denominator, and they're both integers. And of course, the denominator d cannot be equal to 0 because we don't divide by 0. We're going to start by looking at incorrect so-called solutions and seeing that they don't work. So these are solutions, and I put that in quotes, that seem to have an appeal, but they don't actually get to the heart of how we're going to be able to change the expression 1/3 plus 1/5 into a fraction. So the first one we're going to look at is 1/3 plus 1/5 equals 2/8. Now, the appeal here is that we're adding the numerators and adding the denominators. After all, this is addition, so you might think that this would work. Well, let's take a look at it. If I take 1/8 and put it under here, and then get a second one by copying that, I can see clearly that the length that I have from 2/8 is not the same as the length that I have from 1/3 and 1/5. So that solution fails. All right, let's go and look at the next one, which is 1/3 plus 1/5 equals 2/3. Here I'm adding the numerators. 1 plus 1 is 2. And I'm taking the smaller of the two denominators. So I'm taking one from the larger fraction, which is the smaller denominator, and using that in my proposed solution. Well, I'll move these 8s out of the way, put them in my garbage pile. And now I'm going to go get 1/3 and 1/5, and I'm going to say, oh, I already have that at 2/3. Well, I already have 1/3, so to get 2 of those, I'll just copy them. And I can see that 2/3 is considerably bigger than 1/3 plus 1/5. I mean, after all, 1/3 is equal to 1/3, and that would mean that 1/5 would have to be equal to 1/3 in order for that to pan out and actually be equal, and that's clearly not the case. So that proposed solution fails. Well, I'll get rid of this as well. Next one, I need 1/3 plus 1/5 equals 2/5. Awesome, I just need fifths, so I'll take this third and get rid of it as well. Well, 2/5, I can copy that. And although I'm going in this direction, we can see that they're certainly not equal. After all, the length in one direction is the same as the length in the other direction. But if you want, I can move it over and compare them all in the same direction. And then once again, you can see that 2/5, 1/2, is less than 1/3 plus 1/5, so that doesn't work. Well, by now, you may wise up and say, I know what I'll do. I'll add the numerators, but I'll average the denominators. 3 plus 5 is 8. 8 divided by 2 is 4. So the average, right in between 1/3 and a fifth are quarters, right? I mean, after all, here is a third, right? And here's a fifth, and in between are quarters. So I'll take that two of them and see if that works. So there are 2 quarters, and it's closer than anything we had before, but it's not quite there. And so that solution doesn't work either. So much for our incorrect solutions that had certain intuitive appeal because we were adding portions, but that's not good enough. We need to get it to be exact. So what we want to do is use fraction equivalence. If we multiply both the numerator and denominator of a fraction by the same number, other than 0, we get an equivalent fraction. So here's A over B. That fraction is equal to, so it's an equivalent fraction to A times C and B times C. Notice the C value has to be the same in the numerator and the denominator. And of course, it can't be equal to 0 because then we would end up being dividing by 0. So we can see this if we look at the fraction wall. Well, let me tidy this up. And we're going to look at 1/3 and 2/6. So over here on the fraction wall, here's 1/3. And if we follow the line down, we find that it exactly matches with the 6 when we have 1, 2 of them. That means the lengths are exactly the same, and 1/3 is equivalent to 2/6. We can see that algebraically because we can see that we can change 1/3 to 2/6 by multiplying both the numerator and the denominator by the same value. And so 2 is that value. 1 times 2 is 2, so we get 2 in the numerator, and 3 times 2 is 6, so we get 6 in the denominator. Notice that we have that here. Here's another example. 3/4 is equivalent to 9/12. If I come over here and look at 3/4, 1, 2, 3, and follow the line down, oh, I don't have 12ths here. I'll change that so that we have 12ths. And here we are. Here are my 3/4, and follow it down all the way to 12ths. Then I end up having 9 of them be equivalent. I'm going to count in the direction from to the left to see that I have 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And algebraically, 3 times 3 is 9, and 4 times 3 is 12. So 3 is a common value that I can multiply the numerator and denominator by to get an equivalent fraction, and then I can see that 3/4 is equivalent to 9/12. We're going to use this idea to allow us to add 1/3 plus 1/5. The solution is to replace 1/3 and 1/5 with equivalent fractions that have the same denominator because we already know how to add fractions when the denominator is the same. So that's our strategy. What we're going to do is we're going to break the 1/3 piece up into more pieces and the 1/5 piece up into more pieces. And so we're going to break them up so that they're the same size pieces. That's the common denominator. And then however many pieces we have will be the answer to 1/3 plus 1/5. Well, it turns out that in order to do that, I'm going to need to get to 15ths because 15ths is going to be the common denominator because it's going to be the common multiple of 3 and 5. So 1/3, if I look on the fraction wall over here, right, 1/3, and if I come down and look at it in terms of 15ths, all the way down here, I have 1, 2, 3, 4, 5 15ths. And if I take a 5th and bring that down all the way here, oops, I have 1, 2, 3 15ths to a 5th. Let's look at that in terms of the algebra over here. 1/3 can be changed into 15ths because I can multiply the numerator and denominator by 5, and I get 5/15. And 1/5 can be changed into 15ths by multiplying the numerator and denominator by 3. Well, let's check and see if that works. Let's bring out 1/3 and 1/5. And now I'm going to go and get my 15ths. So I'll go and get this one and put it here. And now I want to see that that's one of them, 2, 3, 4, 5. 5/15 was equivalent to 1/3. 5/15 is equivalent to 1/3. And copying some more, I have 1, 2, 3 of them equivalent to 1/5. So 1/5 is equal to 3/15 because I get 3 of them for each fifth. And up here, I got 5 of them for each third. Well, what do I have then? I have 5 plus 3, or 8 of them. So 8/15 is the value that I should have for 1/3 plus 1/5. 1/3 was changed into 5/15, and 3/15 is the equivalent of 1/5. And now when I add them, 5/15 plus 3/15 equals 8/15, and I have my answer. Well, that's it. We're done.